Here is another very interesting example for you to understand linear relation and rate of change. As you've done with other examples, you need to analyze this particular graph, interpret the situation, write a story, and answer the given questions, right? So let's go through these things once again. So here we have a graph which shows distance with time. Time is in seconds and distance is in meters. Time is the independent variable along the horizontal x-axis and distance is the dependent variable along the vertical y-axis. As you see in the graph, the line is sloping downwards and the distance is decreasing with time. So once you get all these things, then you can think about a situation and make a story, correct? So let's go through these questions once again. So first part is interpret the given situation. To interpret, as we analyze your graph first. We have given you a hint, which is walking in front of motion sensor. So that could be a part of your story, right? You can add things to it. You can change it also and make your own story. Now the question is define variables. The first question is define variables. So define variables, write which one is independent variable, which one is dependent variable, what are their units. Then we say what is rate of change. ROC we are writing for rate of change. Now we calculate rate of change. Rate of change, as you know, is the slope of the line. It is change in dependent variable divided by change in independent variable. What does rate of change mean in this particular situation? What is initial value? Initial value means value at time equals to 0. What does initial value mean? And then what would the position be after 10 minutes? That is very interesting question. Explain your answer. So you'll find this explain your answer in very few examples. Here it is unique, and therefore we are asking this question. Think about it. What is the equation of lines? That is your final answer for this particular example. You can stop the video, answer all your questions, and then listen to my suggestions. Okay. So I'm not answering all the questions here, but I'm giving you some suggestions which will help you write good answers. Here are my suggestions. As a part of analyzing a graph, you should always look into the graph first. So when you're looking into the graph, important to note is what are the variables defined on dependent, that is the dependent, and the independent axis of the graph. So horizontal x-axis will represent independent variable, and in this case it is time in seconds. So always associate units with your variable. And dependent variable in this case is represented along the vertical axis as it should be, and it is distance in meters. What we observe here is a line which is sliding downwards. That means a negative slope, coming down from 4 meters to 0 meters in 8 seconds. So this will kind of give you help in answering all your questions, right? Now when you say interpret the given situation, and when you read walking in front of motion sensor, looking into this line, you get an idea that the person is walking towards the motion sensor. So when you walk towards the motion sensor, then the distance decreases, correct? Think like this, that here we have motion sensor, right? Let's say here we have motion sensor, right? and the person is here 4 meters away, and the person is walking towards the motion sensor, right? So once the person reaches this point, then the distance will be 0. At this point, distance is 4. So at times, you can translate these graphs in one dimension like this also, correct? Now, that will help you to answer some of the questions. And I have specifically made this here for you to understand the concept. Okay, let's get back to our story. So walking in front of motion sensor, give a name of the person, let's say John, is walking. You can say John is walking towards the motion sensor from a distance of 4 meters, and he covers the distance of this 4 meters in 8 seconds. You can also add John is walking at a constant rate, since the line is a straight line, constant rate, or at a steady speed towards the motion sensor. Now, defining variables, we already did. Time in seconds along the horizontal axis representing independent variable, and distance in meters along vertical y-axis representing dependent variable. So that is the answer for defined variables. What is rate of change? To find rate of change, you have to find the slope. You should consider 2 points. And in this case, the best points are the initial point and the final point shown here on the graph. So you see that triangle with the line coming down. So rate of change is, if you compare with the equation of line, is basically the slope. Change in rise over run, right? So change in vertical over change in horizontal, right? Rise over run. Since we have distance here, then rate of change can be written as, let's call this as change in distance over change in time, correct? Now the change in distance is 8 is the final distance minus initial was, well, the change in distance is, the final distance is 0, correct? And the initial was 4. So we will write 0 minus 4, correct? That is this distance. So 4 units downwards. And the final time is 8. Initial time was 0. So the change in time is 8 minus 0. Do you see that? So 0 minus 4 is minus 4. So we get here minus 4 over 8, which is minus 0.5 meters per second. Do you see? So that is what we get. So half meters per second you can say, or 0.5 meters per second. Minus indicates that the person is approaching, correct? That is what it indicates, right? So what does rate of change mean here? Since it is a ratio of distance and time, rate of change, and since this is a straight line, we will say the rate of change means a steady or constant speed. You can say constant speed or velocity. If you use the word speed, then you say constant speed of approaching at the rate of half meters per second, or you can say constant velocity of half meters per minute, or 0.5 meters per second. You see that? That is what it means, right? So with velocity you can write minus, with speed you can write 0.5 meters per second approaching. Approaching indicates that the distance is decreasing with time. What is initial value? Initial value is 4 meters. What does the initial value mean? It means that the person started 4 meters away from the motion sensor. That is what it means. That is the initial position. The starting point, right? So that is the starting point. What does the position, what would the position B after 10 minutes. Now every minute it should be seconds because the units are seconds, right? So let me write 10 seconds here, okay? Let me correct it for you. Well, even if it is 10 minutes, we can write the answer, but we'll use 10 seconds currently in this example, okay? Since I've mentioned this time in seconds here. So every second, distance is decreased by half meter. Do you see that? So there are a couple of ways to answer this. Think like this. Every second, distance is decreased by half meter, right? So in 2 seconds, by 1 meter. In 10 seconds, by 5 meters, right? So every second, the distance is decreased by 5 meters. So starting with 4, right? Starting with 4, it decreases by 5 meters in 10 seconds. So 4 minus 5 will give me minus 1. Do you understand? So at 10 seconds, actually, it will be minus 1. Do you understand? Because it is decreasing by half a meter every second. Do you see that? So in 1 second, you can see in 2 seconds, 1 meter. Do you see that? In 2 seconds, 1 meter. So in 10 seconds, 5 meters. So it would be 1 meter negative. Negative means what? Negative means, now let me get back to the initial diagram, which is kind of messed up now. So you started 4 meters away from the motion sensor. In 8 seconds, the person reaches the motion sensor. And then the person goes past, right? And it is on the other side of the motion sensor. 1 meter on the other side of the motion sensor. That is what it means. Do you see that? That's what it means. It goes to the other side of the motion sensor in 10 seconds. It's 1 meter away on the other side of the motion sensor. That is what this negative sign means, right? So what is the equation of the line? Equation of the line, normally we write y equals to mx plus b. Now, y is your dependent variable, which in this case is distance. So it's better to write d instead of y. Slope is m, which is rate of change, right? So rate of change here is minus 0.5. So we get minus 0.5. The independent variable is time, t. So we'll write t in seconds, time, right? And the initial position or the distance was 4. So that will come here. So that gives you the equation of the line for this given situation, correct? In this equation also, if you substitute 10, you will get the answer. 10 times 0.5 is 5 with a minus, which is minus 5 plus 4, right? Minus 5 plus 4 is minus 1 meters. So that is also, you can get the answer, correct? I hope you understand and appreciate this example in full details. I'm going through these details in this example so that you understand and answer the other questions much better. Thank you and all the best.